The last section in chapter 1 has to do with a function. And you're probably familiar with functions already from algebra or from pre-calculus. We often think about functions as being some sort of a line or a curve in the xy plane, but that's really only one type of function. In general, a function is just some rule that's assigning or mapping the elements of one set to elements in another set. And so if we're saying that f is assigning elements of A to elements of B, then we write that f is a function from A to B. That's how we would read this. F is a function from A to B. So f colon A arrow B. So what this is saying is that each element of A is assigned to exactly one element of B. It has to be a good rule. It has to be a good map. If it's saying that one single element of A should go to some element of B and also some other element of B, that's not a good rule, right? That single element of A isn't going to know where to go. So in order to be a function, a single element of A needs to be mapped to just one element of B. All right, so we call the set of inputs, that's A, the domain of the function, and we call the set of allowable outputs B, the codomain of the function. Now, it's easy to sort of get this mixed up with the range because we often hear domain and range talked about together. The set of allowable outputs, that B, is something that's usually given to you. They're telling you this is what A is mapping to. These are your possible outputs. If we want to know the actual outputs of the functions, that's what we call the range, right? So codomain is the allowable outputs, the possible outputs. The range is a subset of that, right? It's the actual outputs of the function. Okay, and finally for, for an input x, there has to be exactly one output as we said. So if that output is y, then we would write that f of x is equal to y, if x gets mapped to y. So let's go through some examples to make sure we understand all these definitions. We can see all that. All right, so in this first example, we have that A, that's the domain, is the set containing x, y, and z. B, the codomain, is the set containing 1, 2, 3, and 4. And I'm going to draw a diagram to explain what the rule of this function is. So this diagram is telling me that x is mapping to 2, y is mapping to 1, and z is mapping to 4. This is a perfectly good function, right? The domain is given to us. That's A. That's the set containing x, y, and z. The codomain is the allowable outputs. That's also given to me. That's B. That's 1, 2, 3, and 4. Notice, not all of these outputs actually ended up, or not all of these possible outputs ended up being outputs of the function, right? They didn't all get used here. So the range is the set of the actual outputs of the function, right? The range is just, okay, well, 1 is in the range because it's the output of y, 2 is in the range because it's the output of x, and 4 is in the range because it's the output of z. So the range is just 1, 2, and 4. So the range is always going to be a subset of the codomain. Right? Every element of the range has to be an element of the codomain, but it might not be equal. It could be equal, but it's not necessarily equal. We would also say, using this notation, that f of x is equal to 2, because x gets mapped to 2. F of y is equal to 1, because y got mapped to 1, and f of z is equal to 4. Right? So this diagram tells us everything we need to know about this function. Now, sometimes it's easier to describe a function as an equation if their function is following some particular rule. So let's define a function f from n to z, remember this is the natural numbers to the integers, by f of x is equal to negative 2x. How would we draw a diagram to represent this function? Well, it's probably going to help if I just sort of give myself some examples to start with. So if f of x is equal to negative 2x, that means anytime you take an input x, that's a natural number, the output is just going to be negative 2 times that same number. So if I start with the input 1, the output's going to be negative 2 times 1, which is negative 2. If I start with an input of 2, the output's going to be negative 2 times 2, or negative 4. If my input is 3, my output's negative 2 times 3, so it's negative 6, etc. So we see what we end up getting here. Anytime we input a natural number, we output negative 2 times that number, so we end up with all these negative, even integers as our outputs. All right, so what's my domain? Well, they told us the domain was the natural numbers. They told us the codomain, the possible outputs, are going to be the integers. But the codomain's not going to be equal to the range, because the only types of numbers we're going to get out of this function are negative 2, negative 4, negative 6, negative 8. It's going to keep going in this pattern. We're only going to get negative even integers as outputs. So my range is going to look like -4, -6, dot, 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 right? Negative even integers. And my diagram is going to look like, well, here's my domain N, here's my codomain Z. I have to try and draw all of these integers. Obviously, I can't really do that, but I know that in my diagram, 3 is going to get mapped to -6, nothing's going to get mapped to -5, 2 is going to get mapped to -4, nothing gets mapped to -3, 1 is going to map to -2, nothing maps to -1, and then I'll just do dot, dot, dots. Right? It keeps going in either direction here. Right, so there's some stuff that doesn't get hit by this function. All of these odd numbers, anything positive, that's not going to be an actual output of the function because our range is just the negative even integers. All right, finally, consider the rule f defined by f of 1 is equal to a, f of 1 is equal to b, and f of 2 is equal to c. Is this going to be a function from a, from the set containing 1 and 2, to B, the set containing A, B, and C? Well, let's think about what this diagram will look like. Here's our domain, our would-be domain containing 1 and 2, our would-be codomain containing little a, little b, and little c. This is saying 1's getting mapped to A, 1's also getting mapped to B, and 2's being mapped to C. Is this a good rule? Is this going to be well defined? No, because where's 1 supposed to go? Is it supposed to go to A or to B? This isn't well defined. I don't know where 1's going to. So not a function. Remember, each input needs to have exactly one output. 1 has 2 different outputs. And that's not allowed in a function. Okay, well, what about the reverse of that? Could you have 2 different inputs giving you the same output? As it turns out, the answer is yes. So let's look at some examples here. Do each of these diagrams represent a function from x, that's 1, 2, 3, and 4, to y, a, b, c, and d? So there's 4 diagrams here. You might want to pause the video and look at these 4 and see if you're, see if these seem like functions or not, right? So let's go through it. All right, in this first example, 1 gets mapped to D, 2 to A, 3 to C, 4 to B. Nothing wrong with this, right? This is a function. Every input has exactly one output. How about the second diagram here? 1 goes to D, 2 goes to A, 3 goes to A, 4 goes to B. Again, this is fine, right? It might seem like a problem maybe that C is actually doesn't get mapped to by anything, but we've seen before that that's okay. That integer, that function from the natural numbers to the integers left out a whole bunch of things from the range. So that's allowed. You're allowed to have something that's not mapped to anything. Or I'm sorry, you're allowed to have something that isn't mapped to from anything. You also might think that there could be a problem here where f of 2 is equal to A, but also f of 3 is equal to A. That's allowed. You're allowed to send different elements of the domain to the same element of the codomain. That's okay. Right? The only problem would be if you had 2 different arrows coming out of 1, or 2 different arrows coming out of 2, or 3, or 4. Right? But as long as each element of the domain has exactly 1 arrow coming out of it, you're fine. Right? It's going to be a function. So this is also going to be a yes. This third function, or this third diagram here, is this going to be a function? Well, here's the problem we were talking about before. We have 2 arrows coming out of this element of the domain. We have that f of 2 is getting mapped to B, but it's also getting mapped to C. This can't happen. You can't have a single input with 2 different outputs. A single input cannot have 2 different outputs. So this is not a function. And finally, here, all right, we have a single arrow coming out of 1, 3, and 4, but what about 2? Right, remember, they told us at the beginning that the domain, or the would-be domain, would be 1, 2, 3, and 4. And so if you have an element of the domain that's not being sent anywhere, this is not a good function either, because 2 doesn't know where to go. Right, you had too many instructions in this one, you have not enough instructions here. So this is not a function, and that's because f of 2 is undefined. right? So the key here is we want to make sure that there's exactly one arrow coming out of every element of the domain. Now, sometimes we want to not allow for something like this. We don't want it to be the case that two different elements of the domain are mapping to the same thing, right? For example, if your function is representing, let's say, an assignment of jobs, where these are your people and these are your tasks or jobs, maybe you don't want two different people doing the same job, so you want to make sure that every input is getting its own unique output, right? Or maybe you want to make sure that there's nothing left over in the codomain. You want to make sure that everything gets mapped to by something. If these are jobs, you want to make sure that everybody is, at least one person is doing every job. And so we have these special types of functions that satisfy these extra criteria, right? So we would call that first case a one-to-one function. So a function from A to B is going to be one-to-one as long as no two elements of A have the same outputs in B. Right, so I'm just sort of giving you two different diagrams here. In the first case, it's definitely a function, and it satisfies that every element of the domain gets its own unique output, right? No two elements in the domain get mapped to the same element of the codomain. So this is one-to-one, right? No two people are going to be assigned to the same task. Everyone's getting their own unique output. But this example here, this is going to be not a one-to-one function. It's still a function, but it's not a one-to-one function. And that's because we have two elements of the domain mapping to the same element of the codomain, right? Those two elements are getting mapped to the same element of the codomain, right? Those two people, for instance, are getting assigned the same job. And so this is not a one-to-one function. We say that a function is going to be onto if every element of the codomain is in the range, right? Another way of saying this is if the codomain is equal to the range, right? We know that the range is always a subset of the codomain. This is saying they're actually equal. Every element of the codomain gets mapped to by something. So in this first example, every element of the codomain does get mapped to by something, by at least one thing in the domain. So this is an example of a function that is onto. Everything in the codomain actually gets mapped onto by something in the domain. But this example here, this is not onto, because we have this element in the middle, this guy here. There is an element of the codomain that's not in the range. Right, that's not an actual output of the function. That makes this an example of a function that is not onto. Now notice, in this example here, while this was an onto function, it's not a one-to-one function, right? Remember, in a one-to-one function, you can't have two elements of the domain mapping to the same element of the codomain. That's what happened here. We had two elements mapping to the same element of the codomain. So this is not one-to-one. Similarly, this function, while it is one-to-one, is not onto, because there's an element of the codomain that's not in the range. In some specific cases, you could have a function that's both one-to-one and onto, and we would call that a bijection. Now that can only happen if you have the same number of elements in the domain as you have in the codomain, but we'll talk about that a little bit more in the exercises. So just to give you one more example, let's say we define a function from the natural numbers to the natural numbers by f of x is equal to x plus 1. Is this function a bijection? Well, let's try to draw a picture first of all, a diagram. So here's my domain, here's my codomain. 1, 2, 3, 4. Here's my codomain. Same set for the domain and the codomain, that's allowed. And this function is saying take your input, your output's going to be that number plus 1. F of x equals x plus 1. So f of 1 is going to be equal to 2. F of 2 is equal to 3, etc. So this is just sort of shifting everything up by 1. Is this function one-to-one, and is this function onto? Because we're trying to find out if it's a bijection. That means we have to check two things. Is it one-to-one and is it onto? Well, to be one-to-one means two different elements of the domain are always going to map to two different elements of the codomain. Is that true here? Yeah, right? We're not going to get any issues like this. We're not going to have any two elements in the domain mapping to the same element of the codomain because everything's mapping to just that number plus 1. So this function is 1-to-1. And we can justify that by saying if you pick, let's say, two elements, let's call them x and y of the domain, they're guaranteed to map to two different outputs as long as x is not equal to y. Right? If you actually pick two different elements of the domain, you're guaranteed to get two different outputs. Right? If x is not equal to y, then f of x is just going to be x plus 1, and f of y is just going to be equal to y plus 1. And if x is not equal to y, then x plus 1 is not equal to y plus 1 either. So f of x is not equal to f of y, and so this function is onto. Okay, oh, sorry. Oh, no, it's 1-to-1. My bad. Right, 1-to-1 means different elements in the domain mapped to different elements of the codomain. That's not the same as onto, right? Onto means every element of the codomain, every element of n gets mapped to by something. That's almost true, except what's going to map to the number 1? Right? 1's going to map to 2, 2's going to map to 3, etc. Everything's mapping up by 1. So nothing actually gets mapped to 1. Right? We have this first number here in your codomain, nothing maps to it. So f is not onto, and that's because 1 is an element of the codomain, but 1 is not an element of the range. So the codomain is not equal to the range, and so this function is not onto. To be a bijection, you have to be 1-to-1 and onto. Since we're not onto, that means f is not a bijection. We'll see some more examples in the exercises.